Hello, Calculus AB. So we are here today for a super important lesson. We're going to talk about the intro to derivatives, and this is going to have a couple different parts. This is the first video. So I want to go over some vocabulary first off. So when we say the phrase a tangent line, and this is going to be really big, a tangent line is a line that is parallel to a curve at one point that has the same slope as that curve. So for example, if I have a function which looks like this. Okay, if I just pick a point, say right there, and I draw a line that goes through that point, but kind of like touches the curve just at that one point, that's a tangent line. I can pick a point over here, and I just touch the curve at that one point, that's a tangent line. Okay, and that's actually going to be our goal today, is how do we find the slope of that tangent line? Can we come up with an equation that tells us the slope of that tangent line? Because it turns out to be extremely useful. I want to turn your attention to one more phrase. A secant line, and this is going to be related, just like tangent and secant are. A secant line is a line that goes between 2 points on a curve. Okay, so for example, if I take 2 points like that, and then I just draw a secant line between them, like maybe it goes through more points, so you keep going to the right. But that's the general idea. That's a secant line. If I just pick like a point here and a point there, that's a secant line that goes through those 2 points. Okay, cool. So that's the difference between tangent line and secant line. We're going to be trying to find the slopes of these tangent lines by using secant lines. Okay, so let me just show you one quick picture, and then we'll take a break and get to work. Okay, so here we have an example of just some random curve, and we have a tangent line of P, or the segment of that line. So what we're going to do is go over to some other point. We're going to create the point there, and then we're going to make a secant line between point P and that point. Okay, so in green we see a secant line right here, and in black we see a tangent line. And what we're going to do today is bring those 2 points closer together by using a limit to bring them infinitely close together. We're going to bring those 2 points closer together until that secant line approaches and ultimately becomes a tangent line. So as you can bring the limit of that distance going to 0, you're going to turn that secant line into a tangent line. And that's actually how we're going to find the slope today. Okay, so now what I want you to do, go to the other sheet and please fill out the whole front side, the first page of that sheet, and then we'll go over that again as a class once you're done.